So very good afternoon to all of you present in the physics live class and a very warm welcome in the live class. So today we are going to discuss about the motion of car or motion of any object on a level road. Okay. So if any car is there, okay, and that is taking turns on level road, okay. So what will happen in that case and what are the limiting factor of the velocity that we are going to discuss. Before that, we are a short introduction about the circular motion is there. So you know well about the circular motion. If any object moves in a circular path, then you know there is a centripetal acceleration that always acts towards the center. Okay, so this is a very short introduction about the circular motion. Circular motion. Okay, let's say a body moves in circular path of radius r, then centripetal force acts towards center, that is against the radius. Okay, so you can understand by this way. Suppose person is moving in a circular path like this. It is moving in circular path, and here it is, and it having velocity v. This is a velocity v. Then there will be the acceleration, centripetal acceleration, that will be acting towards the center. This is, let's say, center. This is your AC, is your centripetal acceleration that is acting towards the center, and this AC is nothing, it's a v square by r. So this AC is nothing, it's a v square by r. Means this v is your constant velocity and r is your radius here. So this will be the constant acceleration, or you can say the centripetal acceleration that is acting towards the center. So if there is a centripetal acceleration, that means there will be the centripetal force. Okay, so centripetal force acts along the along the you can say the centripetal acceleration, and this will be your centripetal acceleration, and this force will be your, this force is equal to MAC, and this will be equal to m v square by r. Here r is your radius. Okay, so this will be the centripetal force, and in response of this centripetal there will be the centrifugal force acting. Okay, so this was very necessary to know about the centripetal force which is acting towards the radius. Yeah, along the means which is acting towards the center against the radius. You know, radius vector will be like this. This will be in this direction, but this centripetal acceleration or centripetal force will be always directed towards the center. So coming to the uh, motion of a car on a level road. Motion of a car on level road. Motion of a car on a level road. So let me first share one figure. Okay, then I will explain how these things are going. So let me share that figure. So this is the figure basically, or I can open from here. Okay, that's fine. And I can open right now. This is the case, and we are going to discuss about the motion of car on level road. So someone is waiting in the class. Okay. Okay. So this is motion of car on लेवल रोड. लेवल रोड का मतलब हो गया बच्चे, रोड आपकी क्या होगी, प्लेन होगी. रोड आपकी क्या होगी बच्चे, प्लेन होगी. ठीक है, रोड में कोई ऐसा नहीं कहीं इंक्लिनेशन होगा. सपोज हम लोग अज्यूम करेंगे, लेट्स से अ कार ऑफ मास m is moving in circular path of radius, we can say radius r. You can see from here bache, if car is there and this is the, you can say this will be the radius of this circle. Okay, because this is taking turn, you can see the weight, this mg will be acting downward, and the normal reaction, or you can say the reactionary force, will be acting upward. And you know well bache, if any car is there that is trying to just rotate, then centripetal force will be acting towards the center, and in response to that there will be the centrifugal force that will trying to move body away from the centripetal force. Means ये body, ये car जो है इधर जाने का प्रयास करेगी. That's why the friction force will be acting on a tire towards the center. ये फ्रिक्शन फोर्स बच्चे टायर पे लगेगा टुवर्ड्स द सेंटर. एंड यू नो, ये कार जो है आपकी लीनियर स्ट्रेट लाइन में चलती है, लेकिन जो टायर्स की वॉबलिंग नहीं होती, टायर्स आपका इधर उधर नहीं हिलता है, टायर्स आपका सीधा रोटेशनल मोशन करता है. लेकिन अगर देखा जाए कि इस तरह से वाइब्रेशंस नहीं होता है, इट्स ओनली ड्यू टू द फ्रिक्शन फोर्स. बट दीज टायर्स आर टेंडिंग, मींस दीज टायर्स आर tending to move towards the outside. That's why friction is acting towards the center. Okay, so this is basically, you can say the radius from here. Okay, this is the radius, this is the center basically, you can say. Then friction force, and here the friction force will be static. Why static friction force? You should just understand this. Static friction force, because along this there is not any motion, along this line there is no any motion, the motion is linear. Okay, so we can say then the friction force, static, act along the center, and let mu s be coefficient of static friction. Okay, so in this case what we can write from here, in this case what we can write, let's see it what we can write. So this will be balanced, means normal reaction will be equal to mg, because there is no motion along the vertical plane. So the weight of object will be balanced by the normal reaction. This will be n is equal to mg, or you can write in this way, n minus mg is equal to 0. So that implies n is equal to mg. This is our first equation. And we know what we know. We know the friction force. This friction force is nothing, it's a mu s into normal reaction. We are representing by n here. Okay, so be careful about this. N is your reactionary or normal force. And from the first we can write here the fs. F can be written as mu s into m into g. And now try to understand one more thing from here. Okay, just be concentrate here. the friction force is going to provide the centripetal force. Okay, this friction force is going to provide the centripetal force. So how we can say, how we can write the friction force? The friction force provides centripetal force. Provide centripetal force. So what we can write here, this friction force is equal to mv square by r, and the v is the velocity of the car. Okay, so this car is moving with velocity, you can see v. Okay, this will be mv square by r. Okay, now we can put the value of this friction force from the equation 2. So this will be further written as this. And you know, this friction must be, this friction, whatever the friction force is acting here, this must be greater. Okay, if there will be lesser friction force than the required centripetal force, then there will be no circular motion on a level road. Then it will be not possible to revolve in a circular path. So we should remember this. This friction force must be lesser than or equal to mu s into n, or we can put the value in this case, or this we can put the value in the place of f from here. This will be your mv square by r, and this will be lesser than or equal to mu s into this mg, and mm will be cancelled out, and this v square, you can see from here, this v square is equal to mu s, the radius, and the g, or this will be lesser than or equal to. So from here you can write the velocity can be written as under root mu s, the radius, and g. You can see here will be the sign of lesser than or equal to. The maximum velocity, the V max, what we can write from here, the V max from here can be mu s r into g. It means what? If any car is there, अब बच्चे ये ध्यान से सुनिए, या फिर आप साइकिल चलाना सीखते हैं बचपन में, तो कहीं आप टर्न लेते हैं, जब टर्न लेते हैं तो टर्न पे आप गिर जाते हैं. क्यों गिर जाते हैं बच्चे? गिर इसीलिए जाते हैं बच्चे, इट्स ओनली ड्यू टू दैट कि जो आपका फ्रिक्शन फोर्स है वो प्रॉपर सेंट्रिपिटल फोर्स प्रोवाइड नहीं कर पाता. इसका मतलब ये हुआ कि द मैक्सिमम स्पीड ऑन अ लेवल रोड फॉर अ टर्निंग अ बॉडी कैन बी रिटन एज this under root mu s, that is a coefficient of static friction, into the radius into the g, that is acceleration due to gravity. So this is the case, this is how we can do these things. Okay, so if there will be, means velocity greater than this, object will just slide there. Okay, so let's have one question on the basis of this topic. तो मैंने जो आपको बताया बच्चे, if there is any level road and the car, means a person is there that is driving the car, and he wishes to have some circular turn of radius r in velocity v, then what can be the permissible velocity for him? This will be your under root mu s into r into g. Okay, so let's have one question on the basis of this topic. So going to the page, the whiteboard, this is basically we have discussed motion of car on level road. So this was V max we have determined now. This was your under root mu s r into g. This was the equation we have derived so far. Okay, so question is that on the basis of this topic, find maximum speed, speed with car, speed with which a car can turn on bend without skidding, skidding, बिना skid किए ये bend कर जाए, if the radius of the, if radius of bending, radius of bending is 20 meter and mu s, that is a coefficient of friction between the road and tire, is 0.4. So what will be the maximum speed? Okay, so what will be the maximum speed without skidding? So we can see from here. So we have given r is equal to 20 meter and mu s is equal to 0.4, and g we have to take, let's say, 9.8 meter per second square, or we can say, 10 meter per second square. When it is given 10 meter per second square, means when it is given g is equal to 9.8 meter per second square, then take g 9.8 meter per second square. Otherwise you can take g 10. So we are here, we are assuming 10 only. So we can use the formula V max, that is your mu s r into g. So we'll put the value of this 0.4 into 20 into 10. So what will be the value here? Let's see it. It will be your 8. This will be how much? How much it will be? Let me know. 80 under root 80 will be there. No? So this is your simply you can solve it. No? This is 0.4. 0.4 to the 8, and this will be here 8 into 10. So this is your under root 80. And if you are solving it, it will be nearly 8, 9. 8 point something. 8 point something will be there, isn't it? 8 point, let's say 1 meter per second. So this will be the maximum speed. This will be, you can see, you can say the maximum speed of the car without skidding. अगर इससे ज्यादा स्पीड हो जाएगी बच्चे, तो कार क्या कर जाएगी? स्किड कर जाएगी. इसका मतलब ये हो गया बच्चे कि जब हम इसकी बात करते हैं वेलोसिटी की, इट इज ऑलवेज रिटन लाइक दिस, लेसर देन और इक्वल टू म्यू एस आर इंटू जी. ओके, सपोज आपको क्वेश्चन ऐसे भी पूछता है बच्चे कि अ कार इज देयर, ऐसे पूछ लेगा, अ कार इज देयर विच वांट्स टू टर्न of radius 20 meter and the coefficient of friction is 0.4 meter at speed, let's say they are saying 10 meter per second. What will happen? तो बच्चे क्या करेंगे, आप मैक्सिमम परमिसिबल स्पीड आप यहां से इस फॉर्मूले से निकालेंगे, एंड द मैक्सिमम परमिसिबल स्पीड इज योर 8.1. सो बिलो 8.1 or 8.1 will be the permissible limit. Beyond this, कार ड्राइवर विल जस्ट स्लिप देयर. ओके, कार वाला स्लिप कर जाएगा, वहां पे वो नहीं चल पाएगा. ओके, सो समटाइम्स द क्वेश्चन इज आस्क्ड इन दिस मैनर. ओके, सो दिस वाज द केस ऑफ मोशन ऑफ कार ऑन अ लेवल रोड. सो अब इसी चीज को, अब यहाँ पे बच्चे आपने समझ लिया कि जो सेंट्रीपिटल फोर्स था दैट वाज प्रोवाइडेड बाय द फ्रिक्शन फोर्स. तो मतलब अकेले फ्रिक्शन फोर्स क्या कर रहा था? सेंट्रीपिटल फोर्स प्रोवाइड कर रहा था. हम इस बार ऐसा कुछ करें कि हम क्या करें, अभी तक रोड ऐसे थी, अब टर्न्स में देखिए रोड को हम ऐसे कर दें, टिल्ट कर दें, मतलब एलिवेट कर दें या बैंड कर दें, तो उससे क्या होगा कि देयर विल बी द कंपोनेंट ऑफ रिएक्शनरी फोर्स दैट विल बी आल्सो प्रोवाइडिंग अ सेंट्रीपिटल फोर्स. तो ये किया जा सकता है बच्चे. लेट्स सी दैट. ओके, सो आवर नेक्स्ट टॉपिक इज मोशन ऑफ कार ऑन अ banked road. So let me share the figure first. For a minute. Banked road. Okay. So I'm just sharing the figure. And the topic is motion of car on a banked road. Motion of car. This is topic. Motion of car on banked road. So you can see the see from figure. See from the figure. So this is basically your road, and this is elevated by angle theta. This road is elevated by angle theta. From here you can see the friction force is now, it is also acting towards this. This is also acting towards this. And now you can see the normal reaction is always upward. This is your, in the upward, this is normal reaction, that will be always perpendicular to this plane. So this is normal reaction, and at this side it will be your n cos theta, means component of this will be your n cos theta, and another component of this normal reaction will be at this side, this will be your n sin theta. Okay, so this is your n cos theta, one of the component, and this is your n sin theta, that is one of the component of what? This is one of the component of the normal reaction. Okay, and there will be one more component. Look here, there will be one more component, because once I will draw the diagram like this, we can see the FBD. This is the actual figure actually. If you are seeing FBD of this, suppose this is level road, and this is, let's say this is car, I'm making from point only, and this was the friction force that was acting in this direction. This was your friction force, and the normal reaction was like this, and this was your normal reaction, and this was angle, let's say this is the case, this was angle, if this is angle theta, so this will be also theta, so this will be your n cos theta, and another component will be like this, this will be your n sin theta here. And now you can see, if it is like this, and this will be your mg, that will be always acting vertically downward. And dear students, you can see from here, this will be your 90 minus theta, and this will be your theta. So component of this friction force along this will be f cos theta, and the another component will be along this, this will be your f sin theta. So whatever component you are taking, that should be always perpendicular. And one more important thing, dear students, from here you can see these force, which force? N sin theta and f cos theta is going to provide the centripetal force, is going to provide the centripetal force. So in this case, what happens? In the previous case, only the friction force was there to provide the centripetal force. Now at this time, there is a component of normal reaction is also there, that is also providing a centripetal force. It means what? कि अगर हम रोड को एलिवेट कर देंगे बच्चे, या बैंड कर देंगे, तो कार जो है, कार की जो मैक्सिमम परमिसिबल लिमिट है वो क्या हो जाएगी? इंक्रीज कर जाएगी. अभी जो कार की मैक्सिमम परमिसिबल लिमिट अगर कहीं पे 8 आ रही थी, तो हम उसको 20 कर सकते हैं, 20 मीटर पर सेकंड तक बढ़ा सकते हैं. Okay, so let's have some description of this figure. So we can say, let's say a car is moving on banked road. Car is moving on banked road, having angle of, having, you can write like this, banked road of theta angle. Okay, theta angle as shown in figure, So the component of friction force and normal reaction will provide centripetal force. बच्चे सेंट्रीपिटल फोर्स यही प्रोवाइड करते हैं. अगर ये प्रोवाइड सेंट्रीपिटल फोर्स नहीं करते, तो हमारी मैक्सिमम परमिसिबल स्पीड क्या रहती? कम रहती. सो फ्रॉम FBD देखिए जो मैंने बनाया, दिस इज योर FBD. free body diagram. So from FBD, what we can write? This n cos theta. N cos theta will be equal to the what? F sin theta plus mg. This is our first equation. And this can be rearranged also. How we can rearrange? This can be further written as, we can rearrange this equation. I will rearrange, but for now it is okay. And for another case, you can write this f cos theta and your n sin theta is going to provide the centripetal force. This is equal to mv square by r. So this is our second equation. And we know well, and we know what we know. We know F is equal to mu into normal reaction. And you can see from here, we can write in place of the means F, we can write mu s into n. This F is equal to mu s into n. Putting the value of this in equation first. So it can be written as n cos theta, and we can make this side. So this will be your n mu s, or n mu s sin theta is equal to mg. So from here you can write this normal reaction can be written as your mg upon, we can take n common from here, and this will be your cos theta minus mu s sin theta will be there. This is our, you can say, the third equation or fourth equation. This is our fourth equation. Now we can put the value of this fourth equation in equation 2. We can put the value of this equation. Okay. We can put the value of this fourth equation in equation 2. So we can write here, putting value of n in equation 2. So what else we can get from here? You can see here, we can put here the f is equal to, this will be your mu s into n sin theta. This is your, cos theta plus n sin theta is equal to mv square by r. Can we switch to the next page? Okay, this is the equation where we are going to put the value. If we can take common from here also, the n will be common, and it will be your mu s cos theta plus sin theta is equal to mv square by r. We can take the common, I mean, so we can put the value of n from here. Okay, so I'm switching to the next page. Okay, in the next page, you can see what we have derived till now. So we have got the value. So far, we got what we got. N is equal to how much it was? Mg. Now you can see this is your mg, and here you can write this was your cos theta minus mu. This is coefficient of friction, and this is your static coefficient of friction. This is mu s sin theta. So far we have got this one, and this was your equation 4th, right? And the second equation where we have to put the value, and this was your, you can see, n, this was your sin theta plus mu s cos theta, and this was your mv square by r. This was the case. Now we can put the value of this normal reaction here, and it will be your mg, and here will be your sin theta plus mu s cos theta, and we'll put value here. This will be your cos theta minus mu s sin theta, and this will be equal to mv square by r, and you can just cancel out mm from here, and you can write here the v square is equal to gr This will be multiplied here. And one more thing you can do from here. You can just take sine theta from, cos theta from here and cos theta from here. If we'll take common from here the cos theta, here the cos theta. So it will be your taking cos theta common from here, from numerator and denominator as well. So if you'll take a common here, so it will be your sine theta upon cos theta, and here it will be your mu s only. And here you can see this will be 1 minus mu s sine theta upon cos theta. And now you can see, we can just cancel out this cos theta, and this sine theta upon cos theta is tan theta here also. So this will be your v square is equal to gr, and this is tan theta, this is tan theta plus mu s divided by 1 minus mu s tan theta. You can see from here, and further you can write this v is equal to under root g into r, and this will be your tan theta plus mu s upon 1 minus mu s tan theta. So this is the case. So this is the case of the, this is the case of the velocity. And one more thing you can do here. If you are assuming if theta is equal to 0, means there was no banking of the road. रोड जो बैंकिंग की बात हम कर रहे थे बच्चे, वो प्लेन में है, तो थीटा उस समय क्या हो जाएगा, 0 डिग्री हो जाएगा. If you put theta 0 here, what we can get from here, you can see that this will be your gr under root gr, and here it will be tan theta. Tan 0 is your, basically you can say 1, and this is also 1. This will be your into mu s. So this is the result what we got earlier. This is the result what we got earlier. Okay, and if you are saying if mu s is going to be 0, means static friction, coefficient of static friction is going to 0, then velocity will be 0. It is not possible to take turn without friction. You can just understand, you can just imagine कि अगर फ्रिक्शन नहीं होगा बच्चे, तो ये पॉसिबल नहीं होगा कि हम किसी सर्कुलर टर्न पे टर्न कर जा पाएंगे. ओके, तो ये आपका कितना इंपॉर्टेंट रोल प्ले करता है कोफिशिएंट और मींस फ्रिक्शन, you can understand in a way. And this is a very important derivation, you know बच्चे, this is very very important derivation, and you should aware of this derivation. Okay, so this was the case for motion of the, you can say, the car on level road we have discussed. And at that instant there was only one force, that was a friction force, that was providing the centripetal force. In the second case we have discussed motion of car on a banked road. This was the case when the road was slightly tilted by some small angle. आप देखते होंगे बच्चे, कहीं पे अगर हाईवेज पे देखिए, कहीं पे अगर टर्न रहता है तो एक साइड की रोड थोड़ा सा उठी रहती है. ओके, तो ये किस लिए किया जाता है बच्चे, कि जो मैक्सिमम परमिसिबल लिमिट होती है उस रोड की, वहां पे जहां पे टर्न है उसको क्या किया जाए, इनहैंस कर दिया जाए, उसको इनहैंस कर दिया जाए, अदरवाइज रोज एक ना एक एक्सीडेंट हुआ रहेगा. ओके, सो वी सॉ दैट कि अगर मींस if there is a banking of the road, then there are the two forces, that is your normal reaction and friction force. इनके जो components होते हैं, इनके components मिलके centripetal force provide करते हैं. That's why the speed limiting velocity, or you can say the permissible limit of the you can say the object or a car or a truck increases. So this is the case that is going to be अप्लाइड इन एवरीडे लाइफ की. डेली टू डे में हम मतलब डेली लाइफ में हम देखते हैं कि कहाँ पे अगर कहीं पे टर्न होता है तो ऐसा रहता है. या फिर आप इमेजिन करिए, जो आप हाईवेज पे जाते हैं, कहीं पे भी ये सर्कुलर या कहीं पे भी आप ओवरब्रिज देखते हैं, अगर कहीं टर्न रहता है तो आप देखेंगे जैसा टर्न रहता है उसके अकॉर्डिंग उसमें एलिवेशन दिया गया है. ओके, इज इट क्लियर टू ऑल ऑफ यू और नॉट? यस, लेट मी नो. Let me know. No?
Yes, sir.
Okay. So you have to go through this video again and again for understanding well. Then only you can understand. And you have to just practice this derivation. Okay. Otherwise, it will be, you will forget these things very easily. Okay, so we are just disconnecting right now. I will be connecting after 5 minutes, then we'll complete the next topic, that is a bending of cyclist on a level road. Okay, so there will here is a 5 minute gap, then we'll connect at 3:05, then discuss further, and we'll do certain questions. Okay, that's it for today right now. Thank you.
Thank you, sir.